Okie dokie, so as promised, I said I wasn't gonna be using the other paper, so now I'm gonna go to the lesson. Well, the whole thing has been the lesson. So we're still on solving linear equations, right? So a couple of questions. The identity element of addition, what is it? And also justify your claim with evidence. Well, for addition, the identity element is 0. Why is that? Because any when you add 0 to any number, we get the number, the original number that we started with. So justification, okay, justification with facts, I would say, and I know I'm writing with my left hand, so I'm not trying not to cover everything. Okay. Zero added to any number, okay, results in the original number. Plain and simple. You want an example? Well, the example would be example, right? And you write example. 3 plus 0 equals 3. 5 plus 0 equals 5. So you see we get back the original number and it doesn't lose the identity. Alright, so now let's move on to the next one. Although I did explain this at the beginning of the video, but still. The identity element of multiplication. We've seen this in September, so the identity element is 1. Reason being is that in any number, okay, or actually a number multiplied by 1 results in the original number. So that's what you need to write. Any number multiplied by 1 is itself. Okay? You want examples? Well, I give you examples, but this is not the only thing that you're writing. You're writing the justification, the written justification. So example, 3 times 1 is 3. Okay? Or 4, and I'm going to use the fancier version, 4 times 2. Oh, what? 4 times 1, I'm sorry. 4 times 1 is 4. A times 1 is A. X times 1 is X. So there you go, you have more than enough space. Alright. To multiply by 1/4 is the same thing as dividing by, well, is the same thing as dividing by 4 because, show proof, sure. Let's have a number, let's have 3, right? 3 times the quantity 1/4 is the same thing as, and I'm gonna make this rational number a fraction just so you could see. I don't have to, but I will. So, and we did this before. So 3 is the same thing as 3 times 1, and then multiply by 1/4. When you multiply straightforward, so 3 times 1 is 3, 1 times 4 is 4. You see? So it is the same thing as dividing by 4, because 3/4 is the same thing as 3 divided by 4. Oh, okay. Okay, we've been through this, so right now you should already been exposed to the explanation. So the additive inverse of any number is its opposite. Yes, it is true. I'm not even going to ask you. It is true. Now, proof. Well, the proof is in the following. When no, not when. The sum so the sum of a number and its additive inverse equals the identity element of addition. I know I'm lucky and I'm sorry I'm left-handed, but that's what I can do. So the sum of a number and its additive inverse equals the identity element of addition. I'm just trying to be fancy. And what is the identity element of addition? Which is 0. Okay? And the proof, sure, the proof is the following proof. Okay. 3 plus negative 3 is 0. Remember what 3 plus negative 3 means. 3 plus negative 3, remember that I hate seeing two signs together. So this is the same thing as saying 3 minus 3, which is 0. That's basically it. All right. Now you give more examples, like you could say b plus negative b is going to be 0 because a number and its opposite give you the identity element of addition, which is 0. Wow. Okay. So here, the multiplicative inverse or reciprocal, okay, of a number is found by flipping the fraction. Show proof. Okay. So if you're my student, you need to write down what I'm gonna say. If you're not, you could just understand the proof. So the product, okay, the product, in other words, the multiplication, okay, of a number and its reciprocal there you go. The product of a number, okay, and its reciprocal results in the identity element of multiplication, which in this case is what? Well, you have it up there, which in this case is 1. So you write that down. Now let me give you the proof. For example, if you have 3 over 2, the reciprocal of this is 2 over 3. When you multiply those, you get 6 over 6. 3 times 2 is 6, 2 times 3 is 6, and 6 divided by 6 is 1. See? That's the proof. Okay, I didn't want to use variables because, alright. So then this is a long text about equations and when you were in like little ones and they gave you the box. I already explained that at the beginning of the video. So you have it right here. You could read it if you want to. If you're my student, you must read it. Haha. So anyway, so this is just explaining to you what to do, what not to do, how to undo the properties, which we already went through that at the beginning. Then you have the example right here. See that? And you have undoing the addition of 6 with a subtraction of 6. What you do to one side, you do to the other. Then you have another example over here. It says solve x minus 3 equal negative 5. So if we follow the rules that I gave you, remember the first rule is, do we have distributive property? And the answer is no, hell no. Then the second rule was, do I have fractions? And the answer is no. Third rule was, do I have like terms? The answer is no. Fourth rule is, we have variables on both sides. The answer is no. Fifth rule is, use the additive inverse, okay? And do we have additive inverse? In this case, we do. Look, x is being decreased by 3. Okay, 3 is being subtracted from x. So then I just have to use the additive inverse of 3, which is, of negative 3, which is positive 3. And then we have negative 5 plus 3 is negative 2. You could use the calculator to corroborate that, and boom. Now, The sixth rule was that we have multiplicative inverse, but there is no number multiplying the variable, so we don't even have to get all the way there. Got it? There's another example on how you solve it. You could look at it because I already went through all this in the video. The reason for this one is to go over certain things that I didn't go through. All right, and the solution is -8. If you have questions why this is -8, you could do it. Now, the one step that I've been stressing is that once you have 7x equal -56, I don't want you to divide just by 7 on both sides. No, I need you to use the multiplicative inverse of 7, which is 1/7. Okay? Look, right here. Let's say you have let me see the pen. Okay. This is what you have. You have 7x equals -56. That is this step right here. That's what you have right here. So the 7 is multiplying the x. So I need you to use the multiplicative inverse of 7. Why? Because I need you to become acquainted with that. So look, 1 times 7x is 7x, and then over 7. So in other words, when you say divide both sides by 7, actually before that you were utilizing the multiplicative inverse. And look, -56 times 1 is -56 over 7 is -56 over 7. And then of course you divide, and you get x equals -8. But once again, stress on the multiplicative inverse. You're gonna thank me because now I'm gonna tell you that there are equations that at the end you're dealing with a weird fraction or from the start. So there you go. Okay, so it says your turn. This time write down the variables. Where did I do my turn already? No, I didn't, but anyways, your turn. So what happens here? You have it in your handout. If you're not my student, then you have it right here. So the variable is being multiplied by -5. You see it? Then 7 is being subtracted from -5x. And hold on, I gotta answer the phone. Well, the person who's calling is not calling anymore, so it's okay. All right, where was I? All right, so this is a summary of what's going on. Okay. Then what will you do? Work backwards, undo. We spoke about it. So what am I gonna do? Add 7 to both sides. Uh-oh. So I add 7 to both sides. And then the easy way out is to divide by -5 on both sides. So since you are already used to the multiplicative inverse, I'm gonna pause right now and I'm gonna actually do the easy way, right? And that's what we get. X equals -23. All right, so now let's see how you do this. So here we are going to use academic vocabulary. So it is the same thing, but now what will I do? Well, use the additive inverse of -7. So you see? And then it says, use the multiplicative inverse, reciprocal of the number multiplying the variable. So this time, I'm going to use the multiplicative inverse, and you're already familiar with that. What is the multiplicative inverse of -5? It's 1 over -5. How? Because this is -5 over 1, remember? Oh yeah, Bax, you said it. Alright, and remember what the idea behind the multiplicative inverse is to get rid of that number bothering the letter, the variable. So when you multiply and divide by the same number, they cancel out, leaving you with 1x. What you do to one side, you do to the other. So now 115 times 1 is 115, and then divided by -5 is -23. And that's basically what it is. Alright? Alright, let's do this. So, how many steps? How many steps? Multiplication and subtraction. That's it. Only 2 steps. So then, out of all the things that you're gonna do, okay, you could definitely go like, is there distributive property? And you go like, no. Number 2, do we have fractions? And you say, no. Number 3, do we have like terms? And you go like, no. Number 4, do we have variables on both sides? No. So it all comes down to 2 operations. And these 2 operations are nothing more than the additive inverse, okay? Additive inverse of what? First of all, you said yes. And you say, of what? Of -7. Which is +7. So we bring down the 4x. -7 plus 7, okay, is 0. And then 13 plus 7 is 20. And then the last step is what? You gotta become acquainted with it. Multiplicative inverse. Of what? Of 4. And what is the reciprocal or multiplicative inverse of 4? Well, it's 1 over 4. But Bex, can we just divide by 4 on both sides and that's it? Well, yeah, that's the idea behind the multiplicative inverse. Oh, okay. So anyways, so when you multiply a number and its multiplicative inverse, you get 1, right? 1x. 20 times 1, 20 divided by 4, 5. Okay? Okay, here we go with this one. So let's see now. Once again, number 1, do I have distributive property? No. Okay. Number 2, do I have fractions? The answer is yes, we have fractions. We have fractions. Okay, we have fractions. So I'm gonna find the common denominator. Hello, Becker. There's only one denominator because the rest are 1 and 1. Oh, okay. So 38 is my common denominator. So I am going to multiply both sides by 38. So 38 times -8 plus b over 38, okay, equals to -9 times 38. Okay, remember we're multiplying sides, not just numbers. So on this side I have these 2 terms that have to be multiplied by 38. So it's like the distributive property all over again. Okay, so let's start multiplying. So what is 38 times -8? That's 304. Okay, plus remember here you multiply by this one and now you're going to multiply by this one. Guess what? You're multiplying and dividing by the same number, so they cancel out, right? So that means that this is just b. Oh, back to the best. Equaling to, and now you multiply 38, okay, times -9, correct? And you get -342. Okay, so Now so no distributive property, fractions, yes. And you know what to do, find the common denominator, multiply the whole equation by the common denominator. Then you proceed to step number 3, which is like terms on the same side, like terms on the same side of the equation. Okay, so let's see. Do I have like terms here? No. Do I have like terms here? No. So then now I'll move on to the 4th step. Variables on both sides. Nope, I only have b on one side, so no. Hey. And of course, let's look for additive inverse. Do I have additive inverse? Is there a number that is adding or subtracting? Of course. 304 is not being added to b. No, it's being subtracted from b. You have to understand that this is the sign of 304. So then I'm going to use the additive inverse of negative 304. What is the additive inverse of negative 304? Positive 304. And what you do to one side, you gotta do to the other. So now the question is, what is negative 342 plus 304? I have no idea. I know that this will cancel out, so 0, bring down the b. And this is wait, negative 342 plus 304. Okay, they have different signs, so I have to subtract them. So then this is negative 38, because when they have different signs, you subtract them and keep the sign of the number that looks bigger without the sign. Okay, got it. You're awesome. So that's basically what it is. That's how you solve the equations. All right. So I did solve it for you. I did explain to you, but remember what the instructions are. For this one, we're gonna have to divide ourselves into the conversations. All right. You got the placemats, and this basically doesn't apply if you're not my student. It only applies if you are my student. So how to conduct a conversation? Well, read it right here and let's follow the instructions. Each station should have 4 members and may be a group of 3. Each member chooses a number 1, 2, 3, or 4. Okay? 1 is going to be the speaker of the group. Then we have the placemats with the prompts placed in each station, okay, in each group of 4, for students to choose from, okay, as conversation starters. So anyways, so this is basically how you're gonna do it, right? Then after a while, the speakers will rotate to different stations. All right. What else? Then number 2 will become the speaker, and so on and so forth until everybody has gotten to be the speaker. So number 1 becomes number. Wait. Let me see. I don't know. All I know is that number 2 is gonna become the speaker, okay? And then number 3 becomes the speaker, and then number 4. So let's see now. What do we have here? Okay, so this is the prompt. All right. Unfortunately, I don't have a crazy person with me to talk to, so I could give you an example of it, but maybe I will in the future. So this is your prompt. Prompt number 1, prompt number 2. That means that you have a choice of problems. Okay. Now, what is it that you're supposed to do? Well, you're supposed to engage in academic discourse. So how does it work? Well, for example, this page, actually let me make it smaller because I'm explaining anyways. Wow, why am I explaining this? I don't know. So this, if you looked at the video ahead of time. So here you're gonna have 1, 2, 3, 4 names for the people in your group. Then you have your prompt 1 and prompt 2. You choose your prompt. Now, 1, 2, 3, 4. The 4 members are going to ask questions to the speaker pertaining the prompt. Like, for example, and I'm gonna give you an example. I know that I'm not good at giving examples, but for example, okay, so this is an equation. Is this an equation? Yes, this is an equation. All right, so we need to solve this problem. How do we tackle this problem? Is there a process? Well, yes, there is a process. I believe that there are operations happening in here, and based on our knowledge of equations, if we know what an equation is, then we have to work backwards. Can you expand on that? Can you elaborate? What do you mean by backwards? Well, to expand on what I just said, what I mean is that, remember PEMDAS? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Well, we gotta undo, but going backwards. So instead of PEMDAS, and you can make a joke, right? Like, let's say you have, let's say, okay, speaker notes, speaker response. So if you have PEMDAS, right? And if you wanna go backwards, then you could write, oops, sorry. You could write SATMAP, which is backwards of PEMDAS. I don't know what SATMAP would mean. Okay, Sally, aunt, dear, my, excuse, please, I don't know, whatever you want to call it. So this is the backwards. So then the speaker can continue, right? And it says, okay, so for example here we have the operation of division and we have the operation of subtraction. So which one goes first according to PEMDAS? Well, division goes before subtraction and subtraction goes last. Okay, so then if we are undoing the operations, I guess we should undo the subtraction first. Yeah, but how do you undo the subtraction? Well, with an addition. Oh my God, you're right. You're great. Okay, I understand. And then the questions are written here. Let's say this guy, what's his name? I don't know. Just give me an Drake. Drake ask, what do you mean? What do you mean by undoing and working backwards?
Yes.
So basically, I like something like that. Okay. What do you mean by undoing and working backwards? And then, of course, here is where you record what the speaker set up, what the speaker responded to your question. You don't have to ask 1,000 questions; just ask one. Then the next member of your group asks another question to the speaker, and so on and so forth. Okay, until you can actually have an idea on how to tackle the problem. Then on the next page, oh my God, if you're not my student, don't worry about it. You don't have to like listen to all this. Once you ask the question, all that, and you have an idea, then you go to the next page, which is this one. So you have the prompt, and now it says mathematical evidence. So then written justification, okay, proof, property use, analogy. However you want to look at it, it all means the same thing. It means show work. Well, you got the golden rules to solve equations. So the first thing that you could say is, okay, mathematical evidence. So you start with your equation. Right? And written justification. So we are going to solve this equation, okay, by undoing, okay, depending on what the speaker said, right? Or based on our knowledge of the rules to solve linear equations, first we are going to look for distributive property. Okay? And we can see that there is none. Then we proceed